In Traveling Salesman Sketchpad, one of the things you could do is create a number of nodes, number of random nodes. So we have, let's have 8 of them. And what you could do is you could translate them a certain amount. So let's say we're going to translate them by 400 pixels to the right. And what you could do is on one side, create a shortest tour using the optimal exhaustive method. And then on the other side, you could create another shortest tour, but this time using an approximation algorithm like the nearest neighbor algorithm. And let's color this second one differently so we can see it better and understand it's different. And observe as I move the node on the nodes on the left, nodes on the right also change, and also the tool changes. And you can see how the optimal is going to have a property of never self-intersecting, whereas for the shortest tool generated by the nearest neighbor algorithm, you see some crossover, which tells you that this could not possibly be an optimal solution. So you could get insight into how approximation algorithms work and when they may be better or not. Another thing you could do is once you have decided the kind of shortest tool you want to study. So let's say I want to study the nearest neighbor algorithm. What you could do is you could have this constructed step by step, so you can see when is it failing to behave optimally. So now I'm going to create again the nearest neighbor algorithm tour, but this time I'm going to be able to see how it's being created. This is especially interesting when you have a crossover behavior, so you understand it's always taking the next best decision. But when you come to the last one, obviously you have to connect. So there is some problem with the nearest neighbor algorithm in the sense that it is not always allowing you to behave optimally because it doesn't have a sense of global behavior.